Let's study 9th standard ICSE physics numericals of 3C. This exercise is super tough. Let's do the fourth sum. Force is given, mass is given, and they've asked for acceleration. Force is equal to mass into acceleration. So acceleration is force upon mass, and the answer is 2 meters per second squared. Now the next sum, sixth sum, the force of 10 Newton acts on a body of mass 2 kg for 3 seconds, initially at rest. Whenever they mention rest, it means the u is equal to 0 meters per second. So they've asked for the velocity acquired by the body, that is v. Now the formula is v is equal to u plus at, but acceleration is unknown. So we'll have to find the acceleration first. A is equal to f upon m. F is given as 10 and it's upon 2, so that's 5 meters per second square. Use this value out here, and 5 and time is 3 seconds. So the answer is 15 meters per second. That's the final velocity after 3 seconds. Now, Roman number 2. They've asked for change in momentum of the body. Change in momentum, I can write it as delta P, or you can even write it as P2 minus P1. Momentum is mass into velocity. So change in momentum is change in mass into velocity. The formula is m delta v. You can also write this as mv minus u, because v minus u is delta v, the change in velocity. So now just substitute it to 15 minus 0, answer 30 kilogram meter per second. Now there's another way to solve this. So, or how about this? We know that F is equal to delta P upon T. Force is directly proportional to the rate of change of momentum, or vice versa. Newton's second law. Force, we know, it's 10, time is 3, so 10 into 3 is 30. So again, we can get the change in momentum using this formula as well. But the most important thing here is the units. Don't make mistakes in units. Momentum or change in momentum is always kilogram meter per second. Now in the 8th sum, they have given the mass, and from the VT graph we can even find the acceleration, which is nothing but the slope. And we have been asked to find the force, and force is mass into acceleration. But be careful about the units. This is in CGS units, so convert it to SI first. So first of all, acceleration is change in velocity upon time, that is 20 upon 5, that is 4 meters per second squared. And mass is 0.1 kg after conversion. So force is ma, and we get the answer as 0.4 Newton. In the 11th sum, they've given the mass. The initial speed is 54 kilometers per hour. We can convert it to meters per second. Is stopped. Stopped means final velocity is 0. And applying brakes for time 10 seconds, calculate the force. It's a very good practice to write the data first, which makes the sum very easy. Mass is given u, initial velocity converted to meters per second by multiplying by 5 upon 18. Final velocity was 0 and time is 10. And they want force. So look at this data and tell me which formula will you use to find force. Well, force is m into a, but how do I find the a? Well, a is v minus u upon t. So first we'll have to find a, and then we can find the f. What's the f? It's 720. You see, first I found the acceleration, which was negative, because clearly this is a deceleration. So when I found the force, I got negative answer, but never leave it negative. We simply say it is 720 Newton retarding. It's a retarding force. Brakes are obviously retarding forces. Now mark the 12th sum and the 14th sums as IMP. Bullet of mass 50 gram converted to kg. Initial velocity is given. Comes to rest, so final velocity is 0. Distance traveled is 2 centimeters. It's clearly a case of retardation. Centimeters, so convert that into meters. Don't forget conversions. Initial momentum. Let me write that as P1. Momentum is mass into velocity. Initial, so initial velocity. Answer is this. Final momentum, well, the final velocity was 0, so the final momentum is also 0. Next, they've asked for the retardation cost. Now looking at this data, how can I find A? There is no time given. So that means I can use only one formula. V square is equal to u square plus 2as. V is given, u is given. Acceleration we have to find out, and displacement is 0.02 meters. On solving further, I want A alone. So this goes on the other side, becomes negative, then 0.04 goes down. I get the answer is minus 250,000 meters per second square. Minus sign simply means that it is a retardation. And fourth, they want the resistive force. Force is mass into acceleration. Acceleration was negative, so my force is also negative. But the final answer will be just written positively, and we have to mention it's a retarding force, that is a resistive force. If you forget to put the minus sign and you just write the answer as 12,500 newtons, it's okay for force. Now in the 14th sum, the initial velocity is given, time is given, a retarding force is given, because brakes are applied retardation. First, find the change in momentum. So I've written all the data, first of all. Force is negative because it's a retarding force. Formula is this, change in momentum is force into time. So I'm getting a negative answer, minus 3000 kilogram meter per second. And final answer should always be positive, just mention retardation. Next, they've asked for the retardation. So again, we use the formula. A is equal to V minus U upon T. We'll get a negative answer, but the retardation is 15 meters per second square. And then they've asked for the mass. So again, the formula is force is equal to mass into acceleration. Negative signs go away, 15 goes down, and the answer is 100 kg. If you don't use negative signs and if you just use the magnitudes and get the answer here, it's okay.
Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.